Hello everyone, welcome to Pepcoding. So in this video we are going to discuss the question right view of a binary tree. So let us start. So what you will be given? You will be given a binary tree and you have to print the right view out of it. Okay, so let us discuss the question. So here is our binary tree and we have to print its right view. So suppose there is a person standing in the right of tree and he is viewing the tree from right side. So you have to print all the nodes that comes in his view. So that nodes could be 3, 6, 10, 11. See, the simple logic is if the person is trying to see something, then he can easily see 3, he can easily see 6. He can't see 1 because in a meaning 1 is hiding behind the 6. So if he is seeing the 6, then he can't see 1. If he is watching 10, then he can't see 5 to 0 because these all three are behind 10. So our answer will contain 3, 6, 10 and 11. So this is how our logic will work. See, before discussing this question, right view of a binary tree, we have already discussed the question left view of a binary tree, which is just similar to right view. You will easily be able to differentiate between both the questions. In that question also, we were taking help of a question which was level order traversal. See, level order traversal question is given in level 1 of binary tree. If you want to get detail of this question, then you can watch that question separately, level order traversal. In binary tree. Okay, so I'm giving a brief intro of this question. Level order, what was level order? In level order, we were given we used to take a queue, we used to implement the queue and we used to insert the values one by one in our queue. So what was level order? In level order, we used to first insert 3, then see in level order we were basically working on BFS. See, firstly we were exploring 3, then next level we were exploring means we were exploring all the children of 3. So after 3, the children of 3, then after 3 is done, then children of 1, that will be 0, 2, then children of 6, that will be 5, 10, and then children of 0, which is nothing, children of 2, which is 4, then children of 5, which is nothing, then children of 10, which is 11, children of 4, nothing, children of 11, nothing. So this is how we were used to insert these nodes in our queue. And what was the logic behind that? In each level, see, this is level 0, level 1, level 2, level 3. In each level I'm talking about the left view. Right now I'm talking about the left view. We were printing the very first node value of each level in left view. In this, what we'll do, we have to print very last node of each level. If we'll traverse level order wise, then what will be our answer? 3, 1, 6, 0, 2, 5, 10 and 4, 11. So in left view our answers was 3, 1, 0, 4. Okay, I'm talking about left view. And in right view, what will be our answers? Answers will be 3, last element in each level. Okay, so I'll be marking with some other color. This is right view. Okay, right view. 3, 6, 10 and 11. So how we will implement this thing? See, while we were traversing level order wise, we were making call from first to left children, then to right children. See, when 3 was there, we were calling left children of 3, okay, then right children of 3. But in right view, what we will do, firstly we will insert the root, then we will call its right children. So firstly we will call its right children, so we will insert 6, then we will call its left children, then we will insert 1. Okay, now 3 is done with all its children. Now we will call what? Children of 6. Next turn in the queue is of 6. Then we will call its right children first. So its right children is 10. Its left children is 5. Okay, now 6 is also done. Now it's the turn for 1. For 1, right children is 2 and left children is 0. So we will push this in our queue. Okay, now it's turn for 10. For 10, right children is nothing, left children is 11. Okay, now for 5, right children is nothing, left children is nothing. So let it be. Now for 2, right children is nothing, left children is 4. So we will insert. Now for 0, there is no children. For 11, no children. For 4, no children. So if we will talk about level wise, then 6 and 1 are in same level. 10, 5, 2, 0 are in same level. And 11 and 4 are in same level. So in this also we are basically printing first element of each level. But the difference is we have made the call of right child first and we have inserted left child after right child. And in left view of binary tree, we were inserting the left children first and then after right children. In this, we are inserting right children first, then left children. Okay. So this is what our question was saying. And if we will print, if we will write these things level order wise, then we'll have 3 first, then right children and left children. So right children and left children 6, 1, then right children and left children, so 10, 5, 2, 0, then 11 and 4. So for right view we have made call like this, right children and left children, and then these very first elements are belonging to our right view, 3, 6, 10, 11. Okay, so let us implement this thing in our code. So this is our right view function. We'll work on this. Firstly, what we'll do, we'll create a queue. So let us create a queue. So this is how our queue is created, and what we'll do, we'll push the root value in queue. Okay, this is the very first step. So till now what we have done, we have created a queue like this, and we have inserted the root value in our queue. Okay, now what we'll do, now we will iterate till queue size of queue is greater than 0. Queue dot size is greater than 0. And what we'll do, see, when we were at this level, the size was 1. Okay, when we were at this level, size was 2, and when we were at this level, size was 4, and when we were at this level, size was 2. Okay, so these are the sizes. So we are supposed to find the children of 3, and we have to iterate in this level only once, for one time, and for second level we have to iterate means we have to find the children 2 times, for 6 also and for 1 also. In this level we have to find the children for 4 times. So what we'll do next, we'll also iterate inside this, decreasing the size, and also we will store, make a size variable, and we'll store the size of q. Okay. What next? We have to also maintain an answer vector, so we will create a vector answer, okay, of int type. So vector answer. Okay, now we will push the elements in our answer. Push back, sorry, push back will have underscore between push and back. So we will add the value from front. Value. Okay. So what will be our next step? Next we will remove the nodes from queue. So start removing from front. We have to remove from front. Okay. Now what we'll do? We will be calling the right and left children of the removed node. So if left of remove not equals to null, means we have to insert. See, till now what we have done, we have to iterate in 3. So what we'll do, we have removed 3, and we are going to add the right children and its left children if these values are null. So this is what we are doing. So we have removed, and now we are searching for it. Firstly, for right children, this is the right view of binary tree. So first we'll check right children, and we will push that children in our queue. Sorry. Queue dot push. Sorry, the first call will be for checking right children. So right, then same thing we will do for the left child. So we'll check if there is left child, then push it in the queue. See, if you are not getting these things, then no need to worry. We'll be discussing all these things. We'll also do the dry run. So now at last we'll return our answer. So now let's do for our dry run. I hope it is visible. So what this will do, our queue is created, first root value is inserted, queue dot size is 1 over here, okay, and we are pushing the front value in answer. Suppose this is our answer, and we are pushing the first value in our answer. This was size, so size was 1. 1 is greater than 0, yes. Then remove from front, this is the front, then remove front, and check for its right and left children. Yes, it is having its right children, also having its left children, then push it in the q, and for the next time size will become 0, and when size is 0, this while loop will terminate. So we'll come into this while loop. So q dot size for this time is 2. So 2 is greater than 0. Yes, we will insert front value in our answer. So next is size is 2. Okay, 2 is greater than 0. Yes, remove from the front. So right now it is front is pointing to 6. So we will remove 6 and check for its right and left children. Okay, now size will become 1, and for this time we will remove 1 from here, and we will check for its children, right children and left children. So we'll insert its right children and left children. Okay, for the next time size will become 0. As soon as size becomes 0, this condition becomes false. So we will terminate from while loop and we'll enter into another while loop. So for another while loop, the size is 4. Size is 4. This was another case, this was another case. So size is 4. Answer dot push, we have to push front value. Front is pointing to 10 right now, so we will push 10 into answer, and size is 4 right now, so 4 is greater than 0. We'll remove 10 and call for its right and left children. So its right children is nothing, left will be inserted. Now size will become 3. We'll check for 5. We'll remove 5. 5 has no children. We'll reduce size to 2. We'll check for 2's right and left children. Right children is nothing, left children is 4. So we'll insert 4. Okay, now size will become 1. We'll check for 0. 0 has no children. So now size has become 0. As soon as size becomes 0, this condition becomes false, and we'll come into this while loop. So here size is 2. So 2 is greater than 0. We will remove 11, call for its right and left children, which are nothing. So now size will become 1. Okay. So as soon as size become 1, we'll remove 4 and we'll call for its right and left children, which are nothing. So size will reduce to 0. As soon as size is 0, we will terminate from this while loop and enter into this while loop. Okay, so in this while loop right now q is empty. So q dot size will become 0. This condition will also become false. We'll terminate from, see, we have missed a statement while we were, from where we have missed the, see, I'm doing from here again. So size was 0, we have entered into this, size was 2. When size was 2, then we have to push the front value. Front was pointing to 11, so we forgot to push 11. So now size is 2. 2 is greater than 0. We'll remove 11, call for its children, which are nothing. Then we'll reduce its size to 1. 1 is greater than 0. We will remove 4, call for its children, which are nothing. Then reduce the size. Then size is 0. This condition becomes false. We'll come into this loop, while loop, and here q dot size is 0. So 0 greater than 0, condition false. We'll terminate from this while loop also. Now here, after completing this while loop, we'll return our answer. So our code seems to be correct. So now we will run our code. So it is accepted. Submit the code. Test cases are passed or not. So all the test cases are passed. So I hope you have understood the question and the solution also. So thank you for watching, and we will be meeting in another video with another question.